Alright folks, we are going to try and derive the expression that we saw earlier for Compton scattering. Okay? Alright, so just a reminder, we're going to have a photon coming in and hitting an electron, and the electron is going to go off in one direction and the photon is going to go off in another direction. Okay, so just real quickly to set it up. We've got the following. We've got our photon coming in, and it's got some momentum and energy, and we've got our electron just sitting there. And then what happens, right? It collides, and then we've got our electron going off in one direction, right? And our photon going off in another direction. The angles that these make with our axis are angle theta and angle phi. Okay. So this is before the collision, and this is after. Okay. Alright, so no problems there. No problems there. So if I wanted to look at what the energy is before and the energy is after, I can write up an expression. And if I wanted to find out what the momentum was before and the momentum after, I can write an expression. So let's do that now. Alright, so before the collision we had the momentum of the initial photon is just P1. Since the electron isn't moving, there's no momentum. Afterwards we've got the momentum of the scattered photon, and the momentum of that electron. Okay, so before, after, momentum conservation. We've also got our energy. So we're saying the energy is conserved with this collision. So the energy of the photon plus the rest energy of the electron, that's before. After, we've got the energy of the second photon plus the energy of the electron. Okay. All right. So momentum conservation, and we're saying the energy is also conserved. Okay. All right. So what is the energy going to be for our electron, and what's the energy of the photon, and what are the momentum? What's the momentum of the photons? Okay. So let's see. All right. So what we want to do is remember the following. The energy for our photons is just its momentum times the speed of light. And that the energy is also equal to for a relativistic object, right? So this we can do for our electron, this we can do for our photon, right? Or we've got that the energy is equal to the square root of mc squared plus p squared c squared. Right? I'm going to put the electron now for electron. Okay. All right. Okay. All right. Okay. All right. Very good. So now using these combined with our energy conservation, we get the following. So from the energy equation, we've got E1 plus m squared is equal to E2 plus energy of the photon and the energy of the electron. We're plugging in the relations that we just saw for the momenta and the energy. We've got P1C plus the mass, the rest energy of the electron, plus P2C plus square root mc squared plus P squared. Okay? Alright, we're just plugging in what we know is the energy for the photon and just keeping the rest energy of the electron. And then if our electron's got rest energy mc squared and momentum PE, we got the energy of our electron, okay, our scattered electron. All right, so now we're just going to do some algebra on this thing. We want to we're going to move this over to the left-hand side and square both sides. See where that gets us. So just doing the algebra. We've got that P1C minus P2C m squared is equal to square root c squared plus P. Okay, just moved it over, just doing the algebra. And if I square both sides, then I've got P1 minus P2 squared C squared plus M2 squared plus 2MC squared P1 C P2C. All this then is equal, sorry I ran out of room, that thing squared. Plus P squared C squared. Okay. Let's do our algebra. Square the left-hand side. Alright, we get that. Square the right-hand side, we can just get rid of our square root. Cool. Very good. Very good. All right. Doing a little bit more algebra, because what we're going to try and do is get PE squared all on its own. Okay, we'll try and get this term all on its own. All right.